Welcome to Safety's Everywhere YouTube channel. Dear friends, don't forget to subscribe this channel and share the link with your safety professional friends.
Hello everybody, we will continue combined process. Today our issue is computation of the combined process parameters, and we will see the analytical solution of that computation, and it is again a mathematical issue, and many of you will like it and many of you may not like it depending on your background and interest, but nevertheless this is an important topic and useful one. So, let us have some discussion and try to get as much as possible from this lecture. So, we will discuss Laplace transform analysis and inverse Laplace transform with reference to this particular topic. What is this? That the parameters of the combined process will be computed, and we have again taken most of the material from our that main book, Probabilistic Risk Assessment and Management, written by Komamoto and Hanley. So, I repeat this diagram as well as the fundamental equations because this is what is the crux of the matter for the combined process when we talk about the parameters and distributions of the combined process. So, let me repeat again, you know the densities. So, combined process means failure density and repair density. So, two densities known to you. So, you want to compute the unconditional intensities Wt and Vt. What is Wt and what is Vt already told to you. In fact, in last lecture we have elaborate derivation for this, and we found out these two equations. Now, question is, if you see the equation, is it a ordinary equation, something like which is having the closed form solution, or what way you will compute the Wt Vt? If it is not a closed form, then we most of the times we rely on iterative numerical integration. There are many numerical methods, numerical techniques. Newton-Raphson is one of them. So, what you can do, you can use the numerical integration methods and then find out the value of Wt and Vt. But if you are interested to do it analytically, so Laplace transform analysis can be a good tool. Obviously, you require to know the form of Ft and Gt for Laplace transform analysis, and that is the minimum requirement whether you will go for the numerical integration or the Laplace transform analysis. By 30 minutes of time, we will see the Laplace transform analysis to compute Wt and Vt, and where the failure density and repair density are following exponential distribution. Okay. Because component useful life usually follows exponential distribution. So, that assuming exponential distribution is also realistic. So, let us see what is Laplace transform and inverse Laplace and how it will help us in computing Wt and Vt. So, Laplace transform, it is taught or it was taught to you in your engineering mathematics, particularly in the engineering degrees, the primarily in the second year or in the first year. and if you are student then definitely it is, and if you have gone through this it is in your memory. But if you are an engineer in practice, you have read maybe several years back, so for you it will be difficult to remember all those things. So, I will give you very gist of the Laplace transform and its inverse here and the definition also, so that you can quickly recollect your that time if you are not studying it now. So, here interestingly we will basically talk about a function h t, and we basically are interested to find Laplace transform of it, and this h t function when we basically want its Laplace, we use this equation. That means Laplace of h t is 0 to infinite e to the power minus s t h t dt, and this e to the power minus s t contain one term s. This s basically represent a complex variable alpha plus j omega. Okay. So, now question comes that what is h t? H t can be any function of different forms. So, for example, if we consider that h t is e to the power minus a t, then the Laplace of e to the power minus a t, so you put h t here, so 0 to infinite e to the power minus s t and e to the power minus a t dt, because of that these are all exponential one. So, this will be e to the power minus s plus a and then dt integration 0 to infinite. So, what will happen? Its integration will be 1 by s plus a and e to the power minus s plus a into t is there, 1 t is there, and ultimately 0 to infinite you put, and finally you get this equation. So, if your function is exponential type, then it is easier to get the Laplace transform of it. So, this is what is the definition for Laplace transformation. We will not go into further of Laplace transformation that fundamental issues. We will use here a fundamental properties of or significant characteristics of Laplace transform, which basically helps us in analytically solving Vt and Wt, that unconditional failure and repair intensities. That is this. That means Laplace of into 0 to t h t minus u and h to t u and du, this can be written equivalently this. So, Laplace of integration of these can be written like this. So, see here h1 t minus u is there, please mind it. So, t minus u converted to t only, and h2 u du, that is no problem, and then h2 there it is h2 t only, no problem. But the basic very important one is this. Second one is here is integration. So, now if you recall or if you just see our equation, that what is Wt equation, what is Vt equation, you see that it has two component here, one is ft, another one is integration of this. Now, if we use this property, then this will ultimately lead to this equation. So, Laplace of Wt if we say, then this will be Laplace of ft, that is the first part. But the second part is Laplace of 0 to t, means integration of this. Now, we will rely on this, we will rely on this equation. So, f t minus u become ft and vu du that become vt. So, what does it gives? It gives that if we know ft and vt, then we will be able to compute wt using this Laplace transformation. So, similarly, the other equation, this equation can be converted. Suppose I take the Laplace of this, then this is Laplace of this, and using this formula you can find out this will be Laplace of gt times Laplace of wt. So, this simplification help us in computing our requirement, means wt and vt here, and you see that how it is possible. So, our two unconditional intensities, one is unconditional failure intensity, another one unconditional repair intensity. When it is transformed to Laplace domain, then we got these two equations, this and this equation. These two equation we will use given ft and gt, and we will show you that how the different parameters will be computed. So, now our work starts. We will consider constant failure rate and repair rate. So, if the failure rate is lambda, then this is basically the exponential distribution from the failure point of view. Similarly, you can find out gt from the repair point of view, it will be mu e to the power minus mu into t. Okay. So, in order to use the Laplace the transformation, what are the equation, what are the different Laplace transformation required there? One is relate to ft, another one is relate to gt. Because we do not know vt and wt, that is what we will be computing. So, what is the Laplace of this ft? Laplace of ft is Laplace of lambda e to the power minus lambda t. So, lambda Laplace of e to the power minus lambda t equal to this. This is obvious, because you have already seen what is Laplace of ht, integration 0 to t e to the power minus st ht dt, integration 0 to infinity, 0 to infinity. Okay. So, e to the power, now what you want, e to the power minus lambda t. So, e to the power minus lambda st, ht is e to the power minus lambda t. So, these two combined e to the power minus s plus lambda into t. So, obviously, it will be Laplace of this will be this. So, then mean this equal to integration of this dt, integration of this dt, dt, this will give you 1 by s plus lambda, already 1 lambda is there. So, it is lambda by s plus lambda. So, similarly, if you do this, this will give you mu by s plus mu. So, we got Laplace of ft and Laplace of gt. So, now we will use the formula or that Laplace formula. I do not know why it is happening like this. So, this is the formula. So, LWT equal to LFT plus LFT into LVT. So, we know this is known. So, we will put here. Similarly, from the second equation this is known, we will put that one. So, let us put. So, you will be getting this one, LWT equal to lambda by s plus lambda by s plus lambda into LVT, and LVT is mu by s plus mu in LWT. Now, we are interested to know the WT. So, in this equation put the value of LVT into this equation. Are you not getting this one? Definitely what will happen, this will become lambda by S plus lambda by S plus lambda. LVT means mu by S plus mu into L of WT. That is what is put here, LWT. This portion is this to this, LWT. Now you have a equation where the only unknown is this LWT, but lambda mu S is that complex variable. So you bring this to this side and do the algebraic manipulation. So 1 minus lambda mu by S plus lambda S plus mu into lambda t equal to this, because this one remains. So after algebraic manipulation you will be getting this equation. This is not a tough to do it, it is just you algebraically you manipulate, there is nothing great. So once this is nothing but this, so then lambda t equal to S lambda into this divided by this quantity. So that can be lambda S plus mu, and if I take common S, then that will be S plus this one. So what we require basically, if now if this is my equation, then if I want to find out the WT, so I have to take inverse of this. So in order to find inverse of this, so I can write that WT equal to L inverse lambda S plus mu by S into S plus lambda plus mu. Okay. Now we have to make it compatible to Laplace inverse. So what we do, that lambda into S plus lambda by this quantity we are writing like this. So lambda into S plus lambda by this equal to A by S first part, and that the second part of the denominator B by lambda plus mu and plus S. So now if you solve this equation, what will happen ultimately? You will find out A plus B into S into A lambda plus mu equal to this, and here AB will be equal to lambda, because S and this S terms will be compared and the remaining will be compared. Okay. So from here you may be wondering that how from here how it is coming. So what you do basically, this one, the right hand side you can write this as S plus lambda plus mu, and the top side what will happen, A into S plus lambda plus mu plus B S. This portion is and this portion same, the denominator same. Now question comes with the numerator equality. So here in the numerator side is what, A S plus lambda plus mu plus B S, and this side equal to lambda into S plus mu, this will be lambda S plus lambda mu. So now this side also, that S part you find out, this A plus B into S, A S and B S, and plus lambda plus mu, the remaining portion. Now this S and this S, we will, from this we can find out that A plus B equal to lambda, and also we will find out that is, I think, A into this. So we are also finding out that A equal to lambda mu by lambda plus mu, from this equal to this. So as a result, ultimately you, by solving this, you are finding out A as well, and putting here you are also finding out B. Now in this equation, LWT equal to this one is converted to this. What is this? A by S plus B by this. What is A? A is lambda mu by lambda plus mu. So, lambda mu by lambda plus mu plus into 1 by s. Second one 1 by s plus lambda plus mu into b is lambda square by lambda plus mu. Now, if you take the transform, Laplace transform, what you will get? W t equal to lambda mu by lambda plus mu L transform 1 by s plus lambda square by lambda plus mu L transform 1 by s plus lambda plus mu. So, you all know that what will be the equation. So, 1 by s means it will be 1 and this one will be e to the power minus lambda plus mu into t. So, that is what we got and we are writing in so this is the part. Now, you are doing the inverse. You see inverse, this one we seen in the last slide. Now, we take the Laplace inverse, we will be getting this. L inverse 1 by s is 1, L inverse 1 by s plus lambda plus mu e to the power minus lambda plus mu t. So, this is the fundamental, that is the equation for us. Okay. Similarly, for V t. So, for V t what will happen? You will find out that we have already seen that what is L V t, and then put all those things and you will find out this equation, then take the inverse of it and you will find out this, and finally, V t equal to this equation. The way W t is computed using Laplace inverse, first Laplace transformation of W t followed by Laplace inverse of that quantity, and then what happened, you were getting W t, and the same manner for L V t, and you are getting this equation. This is for W t and this is for V t. So, but keep in mind that we are considering constant failure and repair rate. That means, we are basically constant failure means the useful life period of the component. Okay, so, to recollect again, because this is maybe new for some of you. So, for recollect this again. This one, yes, I am again going back to this. So, what we have done, please remember what we have done. We have considered this, then also we consider g t equal to mu e to the power minus mu t, and then we have computed the Laplace of these as well as Laplace of these, and we already have these two equation earlier we have seen. Then in this equation L V t is put from this equation, so that we will have only equation related to L W t, and that is what you got here. Finally, L W t is of this form, but now in order to get W 2 we want Laplace inverse transformation of Laplace inverse of these. So, to make it compatible to our original that Laplace equation, you are basically finding out, doing algebraic manipulation like this, and then this equation is becoming this. Now, if you want to do this for V t, you can do this because W t is known, L W t is known. Put here this equation, what will happen, mu by this into this quantity, and then in the same path you follow, you will be finding out L V t in this form, this kind of form, not this equation, this kind of form. That is what we have shown to you later. So, then L V t, that it is similarly that we put here, you see L V t, L W t is put, this is basically LWT, this is put here, then 1 minus of this and finally LVT equation is this. Now question is, this is, we want to find out Vt, so we want to take the inverse of it. Now this one should be written in this form, we want A and B, and this A and B are found out and then it is put here. So this is the second equation. So now if you take inverse of Laplace inverse here, you will find out this will be 1 and this will be what again, e to the power minus lambda plus mu into t. So then the resultant equation we got the equations. One is for Wt, this equation, another one is for Vt. So now what will happen if you do not consider the exponential that assumption that the failure rate or failure density and repair density is exponentially distributed with mu and this. In that case, what other distribution, whatever, accordingly you have to do it. Okay, many times you may not, this may not be that much simple, it may be complex, sometimes it cannot be done maybe. Okay. So anyhow, so once you know the Wt and Vt, if you know Wt, then in order to know the expected number of failures within 0 and t, what is the formula? Formula is 0 to t Wt into dt. But Wt equation is known to you, that lambda mu by lambda plus mu plus this, if you put here and take integration, so then the first one is lambda mu by lambda plus mu into t will be coming, second one lambda by lambda plus mu square 1 minus this will be coming. Okay. So if you take the derivative integration of this from 0 to t, you will be getting this equation. This is what is the expected number of failures within time t. And similarly, what is the expected number of repairs? You just integrate this from 0 to t, you will be getting this expected number of repairs. Okay. So this 1 minus this is coming here, and here also 1 minus this is coming here, you derive. Now what is unavailability? Unavailability is expected number of failures minus expected number of repairs. So at what is unavailability at time t? It will be expected number of failures minus expected number of repairs. So that means this minus this will give you this equation. So that means we are able to compute Wt, we are able to compute Vt, we are able to compute capital W0t, capital V0t, and we are able to compute unavailability, which is this. Physically means this is unconditional failure density, unconditional repair density, unconditional failure intensity, unconditional repair intensity, then expected number of failures, expected number of repairs, unavailability of component. So now if you put t equal to infinite is very large, that is equal to infinite, then you will get steady state or stationary unavailability. So in this equation, if you put t equal to infinite, then you will get this quantity will become 0, and then your steady state or stationary unavailability is lambda by lambda plus mu. And if you do little bit of algebraic manipulation here, you will get this equation. So that means what are you doing? Lambda by lambda plus mu, that is my stationary unavailability. So if I multiply this lambda by 1 by lambda mu, and then the denominator also lambda plus mu by then lambda mu, then this quantity will be 1 by mu, and lower one will be 1 by lambda plus 1 by mu. So now what is the lambda and mu? Lambda is the that is basically the parameter of the exponential distribution here, and we have seen earlier that using exponential distribution the mean time to repair will be 1 by mean time to failure will be 1 by lambda, mean time to repair will be 1 by mu, and so that is why 1 by mu we are writing mean time to repair, 1 by lambda mean time to failure, and this. So that means the stationary unavailability is mean time to repair by mean time to failure plus mean time to repair. Similarly, you can find out the availability. You can find out availability once unavailability equation is known. So, 1 minus unavailability will be the availability. So, equation will be like this. Here if you put t equal to infinite, then your availability equation will be developed, and now t equal to infinite, this quantity will become 0 and you will get this value. This can be converted in this manner. So, availability is mean time to failure by mean time to failure plus mean time to repair, and these two if you sum, then that will be 1. So, this example you have seen earlier, same way we found out that there are 15 different TTA time to failure, and also from this diagram we found out that there are 1, 2, 3, 4, 5 repair time. So, time to failure is known. So, what will be the mean time failure? Mean time to failure will be all time to failure divided by the number of observations. Mean time to repair is also all time to repair divided by number of observations. So, that is what you got. You sum of all those the TTF values divided by 15 is 4.36. Sum of TTR values divided by 5 is the MTTR. So, from your experimental data you have all the TTF values, you have all the TTR values, you are calculating the mean time to failure and mean time to repair, and if I know mean time to failure and mean time to repair, then with the derivations what we have obtained earlier, using this you can find out lambda, you can find out mu, you can find out unavailability, you can find out stationary unavailability, you can find out conditional failure intensity, unconditional failure intensity. This is your unconditional failure intensity, this is WT. Similarly, you can find out unconditional failure repair intensity. Okay. So, you can find out lambda t, which is basically conditional failure intensity, which we can find out mu t, which is your unconditional conditional repair intensity. All those things you will be able to compute. Okay. I hope you got it, and if you have any problem, please put question in the discussion forum and try to learn this mathematics as much as possible. Thank you very much.